Hi kids, we will be going with this unit 1 multi-correct questions. You can look at the first question. Consider the given 3-block system. Friction coefficient was given. Friction coefficient static as well as kinetic between the surfaces mu1, mu2, mu3 were given. Okay, so anyway you can rename them. A horizontal force F of constant magnitude is to be applied on any of the block. Choose the correct options regarding the motion of the blocks. If you look at first option and second option, they were like force is applied on S. In third option and fourth option, force is applied on P. So there are two scenarios. So first scenario is when the force is applied on S. When you try to pull it, then the friction is going to make them move and stuff. So instead of seeing like what is the for a given force, okay, anyway they were asking what is that force. So when I keep pulling it, now they can catch up only till certain level. Now if you want to understand till when they can catch up, when you keep moving them, there is a chance of these two can move together or this one, these two can move separately. Now if these two have to move together, I can view it like a 10 kg block where the maximum friction values you can calculate here easily. Maximum friction is 15 here, 20 here, 15 here. So those values you can calculate. So if these two have to move together, they can move with a maximum acceleration when the force is 20. Maximum force on this is on these two together is 20. So the maximum acceleration of these two together is 2. The maximum acceleration of this one alone is because of this 15, which is 3. So the meaning is this guy can always catch up with this guy. So these two will be moving together always. So when you keep increasing the force, there will be slipping between these two, but not between these two. So these two will be moving together with a maximum acceleration of 2 units. When will that happen? That happens when you take the total system together. This applied force minus 15 equals to total mass times of acceleration. So till you apply 45 Newton, these three will be moving together. After that, these two will be moving together with an acceleration 2. This one will be moving with an acceleration more than 2. So if the force F is applied on S, the maximum possible value of F for which there is no slipping between any of the blocks is 45 units. Now in that case, the maximum value of friction acting between R and P, the friction between these two, if you want to find, that is going to be, you can draw the free body diagram of this. Its acceleration is 2, so the force on this will be 10, which will be provided by friction. Now in the next case, again the same thing. When you apply force on this, these two can move together or there can be slipping between them. If these two have to move together, they can move with a maximum acceleration of 15 by, yeah, so this force is 15 and this force is also 15, so they can't move together. If they have to move together, they can move only with 0 acceleration, so they can't move together. Now, so I think we understood they can't move together. Now obviously if they can't move together, this can't go ahead also, so they won't be moving. So these two won't be moving. So if you keep increasing the force, at certain point this will start moving. When you write F, so when this applied force is more than 15, this one will start moving. These two won't be moving at all. So when you apply more than 15, this will start moving and these two won't be moving at all. And they were asking maximum value of friction between S and R. So the maximum friction here is 15, as this is not moving. If the friction here is 15, the friction here also will be 15. Right. Force on the particle moving in xy plane is given by something, x coordinate, y coordinate. Then the work done by this force in moving a particle from some point to some point. So that's the question. So you need to calculate what is the work done by this force. Just to make the calculation simpler, you can write the given force as, this is in xy plane, this is the position vector and this is the unit vector. So you can rewrite the force like this. Then work done by that force will be F bar dot dr bar. Dr bar will be variation. So dr bar you can write it as this much, and you can easily convince yourself R bar and dr bar, R cap and dr cap will be perpendicular to each other by taking dot product of R cap with R cap and differentiation of that. Or there are many ways of doing it. So that's force times displacement. Now when you take the dot product, this dot product is going to be this much, this dot product, they are perpendicular, this dot product is going to be this much, these two are perpendicular. Then you have to integrate. When you integrate, you should be able to see, you don't need to know what is the path. Without knowing that, you should be able to integrate. The meaning is it doesn't depend on the path, so it is conservative. Now if I define at origin potential energy as 0, now once it is conservative, you can define potential energy, work done is negative of change in potential energy. At origin, if I define the potential energy as 0, at any location potential energy is given by this much, then work done is negative in, so then anyway they were asking only, so work done by this force, so we need to calculate what is the change in potential energy. Maybe negative of change in potential energy. So anyway, you know it as a function of r. In the initial case b by 2 comma 0, so the distance from the origin is, sorry, in the, yeah, so b by 2 comma 0, distance from the origin is b by 2, 0 comma 3 b by 2, distance from the origin is this much. You can substitute it back and you can see these two values are same. So this, you are taking from this potential to this potential, so work done is 0, work done by that force is 0. Option B, distance is b, so potential at both the things will be same, so work done will be 0. Similarly, in the third case, when you do the calculation, initial potential energy you will be getting, final potential energy you will be getting, and there is a difference. So you need to calculate work done is negative of change in potential energy. You can find the change in potential energy and negative of that. A parachutist jumps from height 100 meter. He is to, okay, so I will be showing the figure and reading the question. A parachutist jumps from height 100 meter. He is to reach at ground with 0 velocity. For this purpose, he switches on parachute propeller after falling a certain height h. Given that after the parachute propeller is switched on, the acceleration of the man varies as this much, then choose the correct option. So let me say he has fallen a height h, then his speed is going to be root 2 gh by energy conservation or by constant acceleration equation. After this, he has to travel 100 minus h distance in this kind of motion. Now this one you can write as v dv by dy, then you can integrate, and when velocity changes from here to here, the distance changes from this much. So integration. Now after that you can solve, or you can see like you can plug in 80 and you can see RHS and LHS will be equal. So h is 80 will be the answer. The meaning is before opening the parachute he is traveling 80 meters, after that he is traveling 20. So distance covered by the man with parachute propeller switched on is this much, which is 20. During free fall he is traveling 80 and man switches on. So from here to here this is 80, so the time taken from here to here is square root of 2h by g, square root of 2h by g. H is 80, so you will be getting 4 seconds. After 4 seconds he will be switching on. Velocity and acceleration of the particle were given, then they were asking the particle moves with increasing velocity in x direction. Velocity is along positive x axis, acceleration's component along x axis is also in the positive direction, so velocity will be increasing in the x direction. Particle moves in a straight line, velocity and acceleration they are having some angle, in fact 90 degrees. So it is not going to be straight line, it is going to be parabolic. The particle will have constant speed along z axis? No, initial velocity is 0, but acceleration is there, so it will be increasing its speed along z axis. Radius of curvature, if you want to find radius of curvature, you need to find centripetal acceleration. If you want to find centripetal acceleration, you need to find what is the acceleration's component perpendicular to velocity. You should be able to see that is going to be 1 in k cap direction, or if you want to go in traditional way, tangential acceleration will be given by acceleration's component along the velocity direction. So you can plug in the values, then you will be getting I cap plus j cap, which should make sense because this is in the direction of velocity. Now total acceleration is summation of centripetal and tangential, so centripetal acceleration will be given by total acceleration minus this much, which is k cap. That also you can see this component is perpendicular to this. This is velocity and this acceleration I can write it as summation of these two. This is tangential acceleration, this is centripetal acceleration. Now centripetal acceleration should be equals to v square by r. From there you will be getting the radius of curvature. In a lake, stream direction is as shown in the figure. A man starting from point P on the bank wants to move to bank 2 in shortest time. How should he be moving? So the easy way of doing it is by taking x-axis along the river flow on y-axis this way. Now if it has to reach the other end, if y-axis is parallel to this, so if it has to reach the other end in my coordinate system, y coordinate has to be covering this much width, this much distance. So no matter where he is reaching. So if I talk about motion along y-axis, that is sufficient enough. That is the thing which is determining the time factor. And velocity of the flow is not going to affect anything in the direction. So man has to try his best in this direction. So if you write if you write the equation of motion along y-axis, then anyway they were talking about constant velocity. So you can use s equals to ut. So the more u in this direction, the better it is for him. So he has to try this way, then he will end up somewhere here, but he has to try in the direction of PQ. He should swim along PQ, then he will be reaching somewhere there. Body is moving under the action of central force such that its position vector is given, and choose the incorrect statement. See, I think this derivation we have done in the class. In any general case, in any general motion case, position vector will be given by magnitude times of direction. When you differentiate it, you will be getting velocity. Now position vector direction you can write it as cos theta I cap and sin theta j cap. This also you will be knowing. So differentiation of this is going to be this much, where theta dash will be coming into picture. So theta cap is perpendicular to r cap. So again differentiation of theta cap is going to give you something. I think you have seen this derivation in the class. Anyway, that's okay. So let us keep it there. Then we borrowed it, and this is going to be radial, and this is going to be tangential, we call it as. Then if we differentiate it further, if you differentiate this one further, then you will be getting 2 terms from here and 3 terms from here. Then you can replace theta cap dash from here, theta cap dash and r cap dash from here. When you substitute them, you will end up getting this much. This is the general motion, but in this particular case there can be acceleration only along radial direction. So this is going to be 0. This is going to be 0. That going to be 0, if you modify it, it looks like conservation of angular momentum, which should make sense to you. So in this case, velocity, option A, this is correct, and option A, this is also correct, and this should be 0. So option A is going to be correct option, but we need to mark the incorrect statement. So B, C, D is what you are going to mark. Smooth identical logs are piled in stake truck. The truck is forced off the highway and comes to rest on an even keel lengthwise, but with the bed at an angle theta with the horizontal. As the truck is unloaded, removal of the log shown in dotted line leaves the remaining 3 in a condition where they are just ready to slide. The meaning is it's about to move. So this contact is not there. So if theta was anything smaller than that, you should be expecting it to go this way. So you need to find what is the angle theta. For that, if you draw the free body diagrams, if this is theta, there will be mg, but I didn't draw the mg because it is going to be a mess up, and I have resolved mg already, and I am drawing mg sin theta along the incline and mg cos theta perpendicular, sin theta cos theta, sin theta cos theta. Now apart from that, there will be normal from this one onto this one, action, reaction, action, reaction. Apart from that, there is 3 mg sin theta this way, net force for this entire system, net force is 0, everything is in equilibrium. So 3 mg sin theta in this direction, which will be opposed by 3 mg sin theta from here. Again 3 mg cos theta in this direction, so this plus this should be equals to 3 mg cos theta. N1 plus N2 is 3 mg cos theta. Now N1, N2 we do not know, so we need to figure out N1 and N2. In order to figure out N1 and N2, So if I see why this guy is in equilibrium, I can figure out what is N1, but this is unknown, this is unknown. So I will take torque about this point. You can write a net force equals to 0 and you can do also, but I want to avoid this, so I will be taking torque about this point. If I take torque about this point, torque due to this force is 0. Now this net force is 2 mg sin theta. So torque due to 2 mg sin theta, that is perpendicular distance, this is r cos 30. So root 3 r by 2 times of 2 mg sin theta. Similarly, torque because of this force is going to be this perpendicular distance, which is r by 2 times of mg cos theta. Both are in the same direction, which is being opposed by torque due to normal. Similarly, if you take torque about this point, you will get this equation. Now you can see directly, you can get N1 as a function of theta, N2 as a function of theta. So you should be able to understand. I got these angles from equilateral triangle. This is equilateral triangle, 60, 60, 60, and by symmetry you can split into 30 and 30. If this is 60, then this is going to be 60, this is going to be 30. Those angles you can manage. So N1 as a function of theta, N2 as a function of theta you got. So you will be substituting it here. Then there is only one unknown theta. You can get the value of theta. In the system shown in the figure is in equilibrium. The blocks A, B and C are of equal masses. The inclined face is frictionless. The pulleys are light and frictionless. The thread is light and inextensible. The springs are light and blocks B and C are connected to the axles. B and C are connected by rigid links, massless rods. Then acceleration of A just after thread is cut. So you are cutting the thread in one case and you are cutting the spring in one case. So let us see what will happen before cutting. Before cutting, everything is in equilibrium. So this mg, this mg, this mg is balanced by these two tensions. So mg by 2, mg by 2. If this is mg by 2, this will be mg by 2, this will be mg by 2. Now if you draw free body diagram of pulley and C together, mg by 2, mg by 2, mg. So totally 2 mg downwards. So upward force is 2 mg. Similarly, if this is mg by 2, this should be mg by 2. So mg sin theta should be equals to mg by 2. Mg cos theta will be balanced by the normal. So from here you can understand that theta is 30 degrees. This is before cutting. Now when you cut this, then all these tensions are going to disappear. So all these are going to disappear. So you can see this is going to accelerate this way with g by 2. This is going to accelerate downwards with g. If you look at this, upward force is 2 mg, downward force is mg. So it is going to accelerate upwards. This force is not going to change because its extension is not going to change suddenly. Spring force is not going to change suddenly. Similarly, if you cut this spring force is not going to change suddenly. So mg by 2 is not going to change suddenly. It is not going to change suddenly. So this is going to be in equilibrium at that moment. Net force is 0 in this direction. Now for this guy also, this pulley plus this block, total mass is m, weight is mg, upward force is mg. So its acceleration is going to be momentarily 0. If you look at this plus this mass is m, and mg is already acting and mg is acting. So 2 mg is acting downwards. So its acceleration is going to be 2g downwards momentarily. A rectangular uniform parallel pipe slab is placed on a fixed inclined plane of inclination theta with the horizontal as shown in the figure. L and R represents left half and right half of the slab. 4 observations followed by corresponding conclusions are given below. When inclined plane is smooth, force exerted by inclined plane on the right half is greater. When inclined plane is sufficient rough to prevent slipping, then the force exerted by the inclined plane on the right half is more. Sufficiently rough to prevent slipping, the force exerted on the right half is less smooth. So there are two cases, when it is smooth and when it is sufficiently rough to prevent slipping. So when it is smooth, there will be mg normal. So I can resolve mg sin theta, mg cos theta and normal. See, normal I can't decide the direction, but as it is in rotational equilibrium, when I take torque about center of mass and take torque due to pseudo force also, that will be passing through the center of mass. Torque due to pseudo force and torque due to mg were 0. So torque due to normal also should be 0. So normal should be passing through this one. Or you can see, like, you can write F equals to ma for this total thing and remaining half. So you can understand this acceleration will be same. So there won't be any internal force, there won't be any restoring force in between. So whatever happens for this half and this half also should be similar manner. So normal here, wherever it is acting, it will be acting in the similar fashion. So the net normal is going to be here, or normal here and here will be equal. In the similar fashion, as this is in equilibrium, if you try to take net torque 0 about center of mass, torque due to friction should be balanced by torque due to normal. For that, effectively normal will be acting here. So you can kind of understand like more normal is acting here rather than here. Positions of two vehicles A and B with reference to origin and their velocities are as shown. Then they will collide the distance of closest approach, their relative speed and their relative velocity. So you can sit and you can observe the other, you can sit on one and you can observe the other. You can sit on B. When you sit on B, you will be feeling this guy has 20 this way and 20 root 2, 20 root 3 this way. Then you need to calculate what is the net velocity. Net velocity, from there you will be getting option C is correct. And net velocity will be somewhere in this direction. You can see tan theta is 1 by root 3. So net velocity will be making an angle 30 degrees. 30 degrees. So minimum distance is going to be this thing. You can drop a perpendicular. If this is 30, this is going to be 30. Then you need to find this distance is 200 given. So if this is 200 and this angle is 30, you can find this length is 100. Minimum distance is 100 and they won't collide, so only that much is needed, right? An ant travels along a rod with a constant velocity u bar relative to the rod starting from the origin. The rod is kept initially along positive x axis. At t equals to 0, the rod also starts rotating with an angular velocity omega in xy plane about the origin. Then the position, speed and magnitude of tangential acceleration you need to calculate. So after time t, the rod would have rotated by an angle omega t, and with respect to the rod it would have traveled a distance u into t. So it is somewhere here, So I can say position vector is magnitude wise u into t and direction wise it is in this direction, This unit vector I can write as cos omega t I cap and sin omega t j cap. I can say this position vector is magnitude wise this much, direction wise this much. So that will give you option A correct. Then speed. So if you differentiate this, you will be getting the velocity. Again UV rule, if you differentiate this, ut differentiation is u, and this one you will be bringing it as it is, and ut you keep as it is, and you differentiate this, which is going to give you this much with an omega here extra. Then if you find the magnitude of this, then you will be getting the speed. Magnitude of that is going to be, you can see they are perpendicular also. So you can find the magnitude easily, which will give you option B correct. Then rate of change of magnitude of velocity is going to be tangential acceleration. That way you will get option C. If option B is correct, option D is wrong. Or you can find tangential acceleration in another way also. You can differentiate the velocity, then you will be getting the acceleration. Whatever acceleration you got, if you take its projection along velocity direction, you will be getting the tangential acceleration. Now you should understand this and this should be same. Two blocks of mass 2 kg and 3 kg are placed over each other and the system is kept on a smooth surface as shown in the figure. A force of 30 Newton is applied on 2 kg block. Coefficient of friction between 2 kg and 3 kg is 0.6. An observer O1 observes from ground frame and O2 from 3 kg frame. Magnitude of work done by friction in both the frames and kinetic energy in both the frames. So again it's like same previous friction question. I want to see like what is the maximum acceleration possible for 3 kg. Maximum acceleration possible for 3 kg will turn out to be 4 units, that you can understand from the friction here. Maximum friction here is 12 units. So maximum acceleration of this is 4 units. So these two can move together till their acceleration is 4 units. The meaning is if I keep increasing this force till their acceleration becomes 4, that is 5 force 20. Till I apply 20 Newton, they will be moving together, but we are applying 30 Newton. The meaning is they will be moving separately. In fact, friction is going to become maximum, and this guy's acceleration is also going to become maximum, which is 4 units. So friction is going to be maximum. You can see this acceleration will be 4 units, this acceleration, this force is 18, its acceleration is 9 units. So in ground frame this guy's acceleration is 9 units, velocity after 2 seconds will be 18 units, displacement will be half AT square, which will be 18 units. In that case kinetic energy is going to be half mv square, and work done by friction on 2 kg is going to be force times of displacement but with a negative sign, force times of displacement with a negative sign. In this frame this guy's acceleration will be 5 units. So velocity will be 10 units after 2 seconds, displacement will be half AT square, which will be 10 units. So kinetic energy is half mv square. Similarly, work done is going to be friction times of displacement 12 times of 10 with a negative symbol minus 120. A particle is thrown from ground with speed u at an angle theta with the horizontal as shown. If you notice the minimum value of u, so that the particle will cross the horizontal cylinder just grazing at 2 points on it, and theta naught is the corresponding angle of projection, then choose the correct options. So anyway, they kind of said it is going to graze along 2 points, across 2 points. So if you take this velocity is u1 and this v1 and v2 and this angle as beta, so it is like a projectile from here to here. So for this projectile, range is going to be given by this much, and according to the geometry you can see this is, according to the geometry from this triangle you can see this is r sin beta, r sin beta. If this is beta, this is 90 minus beta, this is beta, this is r sin beta, 2r sin beta. Range is, this is range from physics and this is from geometry, 2r sin beta. So from there you are getting the relation between v2 and beta, both are variables. Now you can use energy conservation from here to here. Initial kinetic energy equals to potential energy here plus kinetic energy here. In order to calculate potential energy here, it is r plus r cos beta. Now v2 square in terms of cos beta you can substitute it back. V2 square in terms of cos beta you can substitute it back. Then you will be seeing v1 square as a function of cos beta. So this minimum velocity needed depends on how it is crossing this angle, crossing this location, at what angle it is crossing. So you can see if you want to find minimum value of this, you need to figure out what is the minimum value of this. For that you will be taking help of am greater than or equals to gm. So minimum value of cos plus 1 by 2 cos is root 2. That will happen when these two are equal, that is at 45 degrees. So minimum value you can calculate. From there you will be getting option A is correct. Then they were asking what is the value of theta naught, not beta. This angle was 45 degrees, we figured out. For this has to be minimum speed, but you need to calculate this value. So I can say v1 cos theta is v2 cos beta. v1 cos theta is v2 cos beta. v1 you got from here cos theta, and v2, if you want to calculate v2 you can substitute, this is 1 by root 2. So from there you will be getting v2 also, v2 cos beta. So there is only one variable cos theta, but we need to find tan theta. So I am squaring it so that I will get cos square. If I take it cos square this side, it will become secant square. I can write secant square as 1 plus tan square. So from there I will be getting tan square is this much, which will give you option D. Basically this is a major equation, energy conservation, but just to eliminate this, to convert this into single variable, we have taken help of this thing. Pitch of screw gauge is 1 mm and its circular scale is divided into 100 divisions. When nothing is put between the studs, the zero, okay, I will be reading out the question. Those who are not aware of how screw gauge works, you can look into the video. You will be unwinding it this way, you will be loosening it this way. Pitch of screw gauge is 1 mm and circular scale division is divided into 100 divisions when nothing is. So from there you can calculate what is one circular scale division equivalent to, that is least count. Then 450 degrees, one full rotation is 360 degrees, 450 degrees refer to 1 and 1/4. 360 degrees and 90 degrees, 1 and 1/4. So 1 and 1/4 is 125 circular scale divisions according to. So 125 circular scale divisions is equivalent to 125 into this much, which is 1.25 mm. So when nothing is put between the studs, 0 of main scale is not seen, but when circular scale is rotated by 450 degrees, 0 of the main scale is just visible and 0 of the main scale coincides with the 0 of the circular scale. So if I have to make it look like correct vernier, correct screw gauge, then I have to rotate it by 450 degrees. The meaning is there is an error already. Now when I rotate it by 450 degrees, it is going to show me 0 reading, but in fact the reading should be 1.25. The meaning is the error is negative error, the correction has to be positive. So when I put an object of length this much, it is going to show me 0 reading. If I want to tell what is the correct value of it, I should be adding this factor. So negative error, and we will be adding the positive correction. Then you started rotating, and it is between 18th and 19th division of main scale. So 18 full rotations or 18 main scale divisions happened, and apart from that 34 circular scale divisions also happened, but this happened from the earlier state. The meaning is you have already rotated by 1.25, and apart from that you rotated this much extra. So total length of the object will be summation of all this. Okay, anyway, again I will be reading the question by showing you the solution. In ordinary vernier calipers, 10th division of vernier scale coincides with 9th division of main scale, but in this specially designed vernier calipers, vernier scale is so constructed that 10th division coincides with 11th division of main scale. 10 vernier scale divisions equals to 11 main scale divisions, and somewhere they have given each division on the main scale equals to 1 mm. From here 1 vernier scale division you will be getting. The calipers have 0 error as shown in the figure 1. So there is an error in the figure 1. So if you want to figure out what is the error, you need to see which line is coinciding. That was 7th line here is coinciding with 7th line here. So 7 main scale division is coinciding with 7 vernier scale division. 7 vernier scale division is 7.7 mm. 7 main scale division is 7 mm. So this error is 0.7 mm. So from there you can see there is an error of 0.7 mm. Now in the next case, again then you need to see like what is the length of the object. The meaning is how much you have moved this 0. This 0 was here before, now you moved till here. You need to calculate what is this distance. You can see this is 17 main scale divisions, which is equals to 17 mm, and this is 5 vernier scale divisions, which is 5.5 mm. The difference in these two is going to be 11.5 mm. So this line has moved by 0.7 mm and 11.5 mm. So total length of the object is going to be 12.2 mm, right? Thank you.